So, friends, as I have told you, simple harmonic motion is an oscillation which is a special case of periodic motion. How do we define periodic motion? You have seen in the earlier part of physics, when we studied translational motion, we defined displacement x in a linear case when a body is acted upon by a force F and there is an acceleration A. X was represented by ut plus half a t square, where u is initial velocity and a is acceleration. I can simplify it by telling x is a function of t. Now you can see that as t increases, x goes on increasing. But suppose, imagine a function, imagine a kind of a situation where after a particular time period, let's say after time p, what will be the value of x in this case? X will be, replace t with t plus p, u into t plus p plus half a t plus p whole square. So, if at a certain time t displacement is x, a certain time t plus p, this will be the displacement at t plus p. This is xt. Supposing, I am not telling that it is in this case, supposing xt plus p becomes same as xt. Then, supposing that you take the displacement at a time after another interval p. So, let us tell xt plus p. That is, what will be the displacement? Again, you will put the same figure in this expression. U t plus p plus half a t plus p whole square. Let us call this as x2 and let us call this earlier expression by x1. If xt is same as x1 is same as x2, xt is same as x1 is same as x2, what do you see? You see that the displacement of this particle is remaining same and in fact repeating itself after an interval of p. We can call this type of mathematical function in a different manner. The definition, a neat definition is this. If x is a function of t and x t plus t is a function of f t plus t, that is replacing the t by t plus t. If this value becomes same as this value, then it is nothing but saying the simple thing that the displacement repeats itself after an interval t. This interval is called time period of the function. Time period of the function ft. If this happens, then this is called a periodic function. This is called a periodic function. If that means if ft is same as ft plus t, then ft is a periodic function with time period t. Time period t. Because the displacement is repeating itself after an interval of t, and if t can be a variable, this x depends on this variable, but t can be time, and if it is a time, it is kind of a time dependent function, then this t will be called the time period of the function. Now, what is oscillation? What is oscillation? are every periodic function oscillatory functions? The answer is no. Oscillation is a special case of periodic function where the function moves back and forth between two values on either side of a reference value. It means, to tell that in a slightly more physics term, an oscillation is a bounded periodic function. Bounded periodic function which often repeats around an equilibrium position. An oscillation is a bounded periodic function. It is not unbound. It has a finite value and it moves back and forth around a certain mean value, which can be called equilibrium position or stable position or something. If it moves to and fro, back and forth, then only it is called an oscillation. Otherwise, a function may be periodic. For example, a circular motion is a periodic function, but it is not an oscillation. The movement of the minute hand or the second hand is a periodic function. It's a periodic motion, but it's not an oscillatory motion. Then, what is SHM or simple harmonic motion? Simple harmonic motion is nothing but an oscillation which at every point of time moves with the same maximum displacement. That means if an object goes to a certain distance and comes back to another certain distance around the mean position, as we will know later, it is called amplitude. If the amplitude of the motion remains same over time, which really is not the case because friction comes to play and every oscillation or every simple harmonic motion ultimately dies down and they require energy to pump into the system to make it oscillate back and forth with the same displacement around the mean position. So a simple harmonic motion is an oscillation where the amplitude remains constant over time. It is an oscillation where amplitude remains constant over time. So I think you got the basic fundamentals of an SHM clear. SHM is a special case of oscillation where the amplitude or the maximum displacement from the stable equilibrium position, the mean position, remains same over time. It's an ideal case, as I have told you, because the friction or damping or some dissipative energy comes into play, and as a result of that, the oscillation gradually dies down. So as I told you, to put it in a compact physics terms, oscillation is a bounded to and fro periodic motion about a reference point. Usually, the equilibrium position. Oscillation is a bounded to and fro periodic motion about a reference point, usually the equilibrium position. So the major components of what can qualify as oscillation, what motion can qualify as oscillation are this. It is a periodic motion. 1, 2, it is bounded. 3, it is about a reference point. These three, when a body exhibits these three type of motion, we call it oscillation.